Ammonia reacts with aluminium chloride as shown by the equation. Draw diagrams to illustrate the shapes of, and we've been asked for the shapes of the ammonia molecules and the aluminium chloride molecules, which is telling us that they're both, because they're using the word molecules, then they've both got covalent bonds. So we're looking at the shape of simple molecules using the VSEPR theory. So let's take each one at a time. So ammonia. So nitrogen is in group 5 of the periodic table, and we're attaching 3 hydrogens, each bringing 1 electron into a covalent bond. We have no charge, so we've got 8 electrons overall, or that's equivalent to 4 pairs. Now, if we were drawing 4 pairs ordinarily, we'd probably look at going 1, 2, tetrahedral, 3, 4. But here we've only got 3 hydrogens to attach. So of these 4 pairs, we've got 3 bond pairs and 1 lone pair. And so when we want to draw this, we want to take one of these bond pairs and convert it into a lone pair. That's going to reduce the bond angle in the remaining 3 bonds by 2.5 degrees. So we're looking to draw our nitrogen at the top here, and then to have these 3 bonds that represent at the bottom of our pyramid, and then we want to have a lone pair on the top. So 3 bond pairs and 1 lone pair. We want to indicate the value of bond angle. Make sure you do that between 2 bonds. So I'm going to draw it from here to here because these are a pair of bonds, and in a tetrahedral we would have 109.5, but remember, because one of them is a lone pair, we squash that down by 2.5 degrees, so we're going for 107 degrees. It's our pyramidal shape. Then if we look at AlCl3, aluminium is in group 3 of the periodic table, and we've got 3 chlorines bonded, bringing an electron, so that gives us 6 electrons in total, or 3 pairs. Now if we look at this, there are 3 atoms attached to the aluminium, so this would be 3 bond pairs and no lone pairs, so they're going to spread themselves out completely evenly around the aluminium, and if they do that, they will do that actually in 2 dimensions, because that would give us the biggest bond angle, and we can mark that on 3 things spread out equally around a circle, 120 degrees. So we have ammonia at 107 and aluminium chloride at 120 degrees. Then it says, name the type of bond formed between the N and the Al in NH3AlCl3. So remember that our NH3 had 3 bond pairs and a lone pair, making up 8 electrons around the central atom. And our aluminium chloride had 3 bond pairs and no lone pairs, so in fact there was a total of only 6 electrons around the central atom. So aluminium is electron deficient. It hasn't got a full shell, but ammonia's got a lone pair. And so what can happen when one atom is electron deficient and another has a spare lone pair is that we can get a coordinate bond or a dative covalent bond. Either of those terms would be acceptable, coordinate or dative covalent. And why do we get that? Because both, so this is kind of the definition of a coordinate bond, both of the shared pair of electrons come from the nitrogen in ammonia. So ammonia had a lone pair, aluminium was electron deficient, and they could make a shared pair where both electrons come from the nitrogen. So what would happen then as a result of that to the bond angle in AlCl3 if it makes this compound? So what we've now got, this is without shape drawn on it though, is we've got an N with 3 bonds, and it had a lone pair, but it's now using that lone pair to form a coordinate bond, a dative covalent one, to the aluminium chloride, which had 3 bond pairs. So now if we look around, both the nitrogen and the aluminium now have 4 covalent bonds. The coordinate bond is just a type of covalent bond. So aluminium now has 4 bond pairs and no lone pairs. And so its bond angle has gone from what would have been 120 before that we had in aluminium chloride trigonal planar to 109.5, because it's now 4 bond pairs, no lone pairs, it's now tetrahedral. So the bond angle has decreased. So we can write that the bond angle has decreased from 120 degrees to 109.5 degrees, as there are now 4 bonded pairs of electrons around aluminium.